Biomass, a renewable energy source, is a biological material derived from living or recently living organisms such as wood, leaves, paper, food waste, manure, and other items usually considered garbage. These resources can be used to provide heat and electricity and transport fuels. The chemical composition of biomass is usually carbon, hydrogen, and oxygen based. There's also nitrogen and small quantities of other atoms, including alkali, alkaline earth, and heavy metals. There are many different technological options available to make use of the wide variety of biomass types. Conversion technologies may release energy directly in the form of heat or electricity, or may convert it to another form, such as liquid biofuel or combustible biogas, in which heat is the dominant mechanism to convert the biomass into another chemical form. Another type of conversion is chemical conversion, in which a range of chemical processes may be used in order to convert biomass into other forms, such as to produce fuel that is more conveniently used. Most importantly, though, because biomass is a natural material, many highly effective biochemical processes have been developed in nature to break down the molecules of which it's composed. These processes can be harnessed for our own use. The conversions in nature make use of enzymes and bacteria and other microorganisms to break down the biomass, using processes like fermentation and anaerobic digestion. Scientists are using and continuing to research new ideas on how to break down biomass so it can be the most efficient. Despite its advantages, biofuel is still not the most efficient technology.
Now that you know what biomass is, a couple questions should arise. One of which being, how could biomass be used to reduce the local dependency on oil or coal in China? Biomass can be used to reduce local dependency in China in many ways. A couple ways that the people of China as a whole can do to reduce the use of coal and oil is to use biomass wood chips over coal and oil to heat their homes in the winter. Another way is by using biomass chips instead of coal while using a barbecue. Not only will this reduce the local dependency on coal and oil, but it will also benefit our Earth by releasing no greenhouse gases. Since biomass fuels are carbon neutral, they do not release greenhouse gases when burned. China is a vast country that has a rapidly growing economy, population, and industries. Therefore, the question arises, where are the best places to input biomass technology? At the moment, China uses a lot of coal because of the new ways to mass produce it. Biomass would not have the time to produce enough energy that cities in China demand. Also, because most of the biomass is in the form of wood or manure, it is very hard to transport due to the weight. However, once China figures a way to produce enough biomass energy just as fast as coal, I believe it should be used nationwide. It should be used in all homes, and industries should try to make their products using biomass energy. Having China using biomass nationwide would benefit them because it's healthier for the earth. The current situation on biomass in China is actually doing quite well. About 61% of energy used in rural parts of China is biomass. Some more examples of current-day biomass used in China is the Shanqian Biomass Power Plant in Shandong Province. It produces about 160,000 to 200,000 tons of agricultural residues per year. That comes from local farming communities. It has a capacity of a 25 megawatt generator. Annual electricity output is around 137 gigawatt hours. It replaces 70,000 tons of standard coal per year, and CO2 emission reductions are 10 million tons per year. 8 straw collecting, storing, and buying stations have been set up to secure waste biomass resources from the farmers in China. The price of biomass when compared to other energy sources such as coal is more expensive at the moment. It takes about 10 billion yuan to produce enough energy to power 3,000 hectares of land, which is equivalent to 7,413 acres. The problem with this is that more coal can be bought to produce more energy with the same amount of money. Due to better tools, coal can be faster mined than biomass produced. However, with such an expensive price, biomass makes up for it by providing money for farmers who help produce the energy.
The favorable payoffs in association with the use of biomass energy are numerous and widespread, given the range of types of biomass energy sources that exist. Here are some of the major positive impacts.
First and foremost is, of course, the fact that biomass is a renewable resource on account of plants and crops can be grown in not so long a time, and waste products will always exist. Another positive environmental aspect of biomass energy is in regard to waste-to-energy biomass fuel. We've all heard that when you throw things away, they don't really just go away. They remain garbage, of course. These wastes are likely to be buried in landfills or left in fields to rot. Such methods can create environmental threats, namely the release of methane gas into the atmosphere. So if we use what otherwise might be useless garbage to create biofuels, then not only will we have a source of renewable energy, but will also lessen the impact of this harmful greenhouse gas.
A further example is that wood, which is used to create certain biopower, is what is known as a carbon-neutral type fuel. This basically means that during the life of a tree that the wood comes from, as much carbon dioxide is absorbed by the tree as is released in the conversion of energy by burning of the wood.
A related impact is the fact that biodiesel recycles carbon dioxide, in that though CO2 is emitted from, say, exhaust fumes of biodiesel-fueled cars, CO2 is also absorbed by the biomass crops, namely soybeans.
This canceling out of carbon dioxide emissions is not to the extent that make the use of biodiesel a carbon-neutral process. However, biodiesel does sizably cut down on combustion emissions, reportedly by up to 20%. In addition, biodiesel, unlike petrodiesel, is both non-toxic and biodegradable. While both a renewable and greener source of energy, biomass is not a magic answer to all of our environmental problems. It does come with some drawbacks.
For one thing, biomass power plants do produce air pollution. The pollution caused by certain biopower plants sometimes has even surpassed those from power plants dealing with coal or natural gas-based fuel.
The pollutants released into the atmosphere include nitrogen oxide, carbon monoxide, black carbon, volatile organic compounds, among others in lesser quantities. Black carbon is said to be the next largest cause of global warming, and was determined by Swedish scientists in 2009 to originate largely from the burning of biomass. Another downside is that when land is cleared for the planting of biomass crops, the deforestation causes release of harmful greenhouse gases into the atmosphere. It is not only our environment that is affected by the use of biomass for energy. Issues exist as far as people are concerned as well. Major social costs are as follows.
One example of a social cost is how with the production of ethanol, prices of corn as a food product have gone up. As you can see from this chart, corn price in the U.S. increased by 34% from September of 2009 to September of 2010. This would surely apply to other biomass crops as well, like soybeans, whose prices have also soared in recent years.
In addition, ramping up the production of biofuel would mean harvesting significantly more of the energy crops, potentially at an unsustainable rate. A 2007 study from MIT estimated that as much as 500 million acres of American land would be necessary to grow enough biomass crops to replace fossil fuels entirely, which would displace so much cropland that it seemed heavy use of biofuels would just cause America to shift from dependence on foreign oil to dependence on foreign food. Moreover, biofuels in general do not have as much concentrated energy as do the non-renewable type fuels. They also take more handling and a longer process to produce in a power plant, so biomass fuels tend to be pricier. Therefore, governments are subsidizing the cost of biofuels at taxpayer expense. We are coming to the end of this documentary, and the lingering question is, do the costs, monetary and otherwise, of biomass energy make it prohibitive for common use? Are the benefits outweighed by the drawbacks, or vice versa? In short, biomass energy alone will not suffice to replace non-renewable energy sources altogether. In conjunction with other renewable energy-producing technologies, though, it can aid in creating a healthier Earth.